So we've spent some time learning the characteristics, some of the characteristics of functions. Uh, but now we're going to turn our attention to some very specific ones. It's helpful to know the characteristics of uh, the 12 basic functions. You know, things like asymptotes and things like domain and range, because we can then move on to manipulating these 12 functions in any way we like to fit whatever situation we're in. So just today, we're just going to meet the 12. The first of the 12 basic functions is one you should be very familiar with. It's the identity function. F of x equals x for every element of the domain. The function just returns the same thing in the range. So 1, 1's on the graph. 2, 2, negative 50, negative 50, etc. So we can ask some of the basic characteristics. What is the domain and the range of the identity function? Well, obviously, there are no restrictions from negative infinity to positive infinity on the domain, and the same for the range. We'll ask the questions about asymptote. Are there any asymptotes? Clearly no. Are there any extrema with the identity function? No, it does not change from increasing to decreasing. And is the function even or odd, or neither? What do you think? Well, since it has symmetry about the origin, it has origin symmetry. You fold it along the x-axis and then again the y, it would fall on itself. So it is an odd function. The next basic function is the reciprocal function. It takes the reciprocal of any given member of the domain. If x is 2, the function returns a half. If x is 1/2, the function returns 2. Reciprocal function. What is the domain and the range? The domain and range of the reciprocal function? Well, the domain would be any number all the way up to 0, because if x is 0, the function would be undefined. And then it picks up again just after 0 and goes all the way to infinity. The range, you can see from the graph, starts at negative infinity and goes to 0. But then there's trouble with 0 because the reciprocal function will never take that value. So we have to omit 0 from the range. So the range is the same. Are there any asymptotes in the reciprocal function? Well, clearly we can see 2 of them. There's a vertical asymptote at the x-axis, the y-axis, and a horizontal one at the x-axis. These are asymptotes. So we say at x equals 0, that's the vertical asymptote, and at y equals 0, that's the horizontal asymptote. Does the reciprocal function have any extrema? Any extrema? Well, there's a bit of a sideways hump here, but that function is decreasing a lot, but it never goes from increasing to decreasing, so it doesn't have any extrema. Is this function even or odd, or neither? Well, if you plug in negative x, and I think we did that example yesterday, plug in a negative x for x, and do we get the opposite of f of x? And the answer was yes, the function is odd. The next basic function is one you're well familiar with. The squaring function, you might remember it better as a parabola. Its graph is a parabola, or it's a quadratic equation, the most basic quadratic equation. What is the domain and range? Well, you can square any number. There's no restrictions, so the domain is all real numbers from negative infinity to positive infinity. And the range of the basic squaring function, well, when you square any number, you get a positive number or 0. So the range is all positive numbers and 0. Does the squaring function have an asymptote? No, it does not. Does it have any extrema? Yes, it has a minimum value right at the origin, minimum. And is the squaring function even, odd, or neither? You tell me what you think. Well, we can see from the graph that the answer is yes, but just for practice, the answer is it is even. But let's practice doing algebraically. To check whether a function is even or odd, we would ask ourselves, is f of negative x equal to the original function? So plug negative x into the squaring function and simplify. The negative of x squared is x squared, and that's the same thing as the original function, so it is even. Before I move on to the next function, I noticed I made a mistake. I hope you caught it too. The range of the squaring function, the simple quadratic, does include 0, and my expression here with the parentheses in interval notation says that 0 is excluded, but it actually is included, so make sure you record it with a bracket rather than parentheses. The next function that we should be accustomed to, or we'll get accustomed to, is the exponential function. It's where the variable x, the domain values, are the exponent. In this case, the base is the naturally occurring transcendental number e, but it may be other bases. It doesn't change the graph very much. But the domain and range of the exponential function, we can raise a number to any power, both positive and negative, or fractional, or irrational. So the domain is any real number. The range, however, all the possible y outputs, or the y values, will always be positive numbers. And we'll go into that whenever we dig deep into exponentials. So all positive numbers with the exception of, well, excluding 0, are in the range. Is there an asymptote? Yes, the x-axis is an asymptote to the parent function. So the asymptote is the line y equals 0, or the x-axis. Do you see any local or absolute extrema? No, there is not. There's no absolute extrema. It continues forever, and it never quite bottoms out. And this is a perpetually increasing graph. Is this function even, odd, or neither? Well, there is no symmetry, so it is neither. Next up is the cubing function. And we can see that any real number can be raised to the third power. So the domain is, the set of real numbers. And the result can be any real number. So the domain and range are both all real numbers. There are no asymptotes on the cubing function. There are no extrema in the cubing function. And I'll leave it to you to decide whether this function is even or odd. Well, how'd you answer? We'll see. Is f of negative x, doing this algebraically, what does that equal? Simplified. I'll plug in negative x into the function and cube it. Negative x times negative x times negative x. So the result would be the negative of x cubed. The result would be negative. Well, that is the opposite of the original function. So f of negative x is equal to the opposite of the original function f of x. Okay. And so it is odd. Of course, graphically, we can see it is odd because we have origin symmetry. Fold the graph along the x-axis, then fold again along the y-axis, and it will fold right on top of itself. Next up is the square root function. When we take the square root of any number, can you take the square root of any real number? Well, we've asked that question a few times already in the first few days in our exercises, and we know that you cannot take the square root of negative numbers, only positive numbers and 0. So the domain is the positive numbers and 0. And the result of taking the square root of positive numbers is also always positive. And the square root of 0 is 0. The square root function has no asymptote. It has no extrema. And as to even or odd, well, we can see from the graph it has no symmetry, so the function is neither even nor odd. The next basic function we need some experience with is the logarithm function. This expression ln x means the base is e, that transcendental number. But the base, again, could be other things as well, and the graph doesn't change very much. It's the inverse function of the exponential graph. And its domain, as you can see from the graph, what are all the possible x values? Well, looks like they start at 0, but not quite, and go to infinity. And then all the possible y values are all real numbers, from negative infinity to positive. Does the logarithm function have an asymptote? Well, it looks as though there's a vertical asymptote at the y-axis, and that is indeed the case. So there's a vertical asymptote at the line x equals 0, which is the y-axis. There are no extrema in the logarithm function. And can you tell if it's even or odd, or neither? Does the graph exhibit any symmetry? And the answer is no. So neither even nor odd. I think you're familiar with this function, the absolute value function. We know that the absolute value function, you can take the absolute value of any real number, so the domain is all reals, and the function produces nothing but positive values, so the range is all positive numbers, including 0. It actually does have an extrema. The extrema is right here, where the function changes from decreasing to increasing. And that is an absolute minimum. There are no asymptotes. And the function, do you think it's even or odd, or neither? Well, it's clear that it has a symmetry about the y-axis, and that's one feature of even functions. So the function is indeed even. The next basic function is the sine function. It's definitely one that we're going to dig into deeper as the course moves on. But we can see, I guess, from looking at it, that the x values of the domain go on and on. So the domain is all real numbers. And the range of values is not all real numbers. I mean, we only toggle back and forth from a minimum here to a maximum here, back to the minimum, back to the maximum, and it continues that process repeating. So it goes from -1 to +1 and back and forth throughout. This doesn't have an asymptote. This is not asymptotic. It just means that it's going to continue that oscillating pattern. But it does have a new word I'd like to introduce. The function is bounded. It just oscillates back and forth, so it's bounded at the top. It's like it has a ceiling and it has a floor. It just operates entirely between these two boundaries. So that's sort of a new word, a bounded function. It's bounded between two different horizontal lines. There are multiple extrema. There are infinite number of maximum values, and there's an infinite number of minimum values. So there are an infinite number of extrema on a periodic schedule. And we can see from the graph that it does have origin symmetry. If we reflected it about the x-axis and again then the y-axis, it would fall on top of itself. So this is an odd function. And there are 3 more functions we need to talk about, but my recording time is about to exceed my allotted amount, so I'm going to give you part B. That's it for this particular one, but part B coming up.